Hey everyone, welcome to Sources classes. Here is an example of our Durbin-Watson test. So we have already studied about the context and hypothesis testing of Durbin-Watson. So to understand this question, as you can see that we are given y and x, data on y and x, and the model is basically our yt is equals to alpha plus beta xt plus e plus ut. So this is our model. Now these are x and y. So from these x and y we can calculate the following. First one is xt, second is yt, and second is xt. So these are all our yt and xt as given in the question. So this is summation of xt yt. So from here we can calculate y bar. So that is summation yt by n and summation xt by n. And this is how we have got 7 and 8. Apart from that we have the small yt, that is the deviation, small yt square, that is the square values, and then addition, xt, all the square xt, then square values, then xt into yt. Then finally now we have to calculate alpha hat and beta hat to find out the yt hat. That we will see how we can calculate. And then we have to find out et square, et minus 1, and et minus square. So after finding this summation, from these we can find out d, which is our summation et minus 1 whole square by summation et square. So that is why we need the data. Now let us start. So let us first write down the model. So the model is yt is equals to alpha plus beta xt plus ut. So the estimated model yt hat is equals to alpha hat plus beta hat xt. So I have to calculate alpha hat and beta hat. So from the OLS estimator values, I know beta hat is equals to here summation xt yt by summation xt square. Now I know the values from the data that we have calculated. What is xt yt? That is 267, and how much is xt square? 280. So 267 by 280 is equals to 267 by 280 is equals to 0.96 approximately. Next is alpha hat. We know alpha hat is equals to y bar minus beta hat x bar. Now y bar and x bar is also calculated here in the table. That is our x bar is 8 and y bar is 7. So that means the value here is equals to y bar is 7 minus beta hat is 0.96 into 8, which is equals to 7 minus 7.6 approx. That is equals to minus 0.6 approx. Okay, that means our estimated equation is now yt hat is equals to alpha hat is minus 0.6 plus beta hat is 0.96 into x. So this becomes our model. Now using this we are going to calculate our error term. That is here e, right? That is yt minus yt hat. So here we have got the value. So for every value of x, like 1, 2, 3, 4, 5, we are going to find out the estimated value of y, that is these as calculated. So this yt hat minus this original yt, the first column, right? So this column and this column, if we take the difference, then we get the error term, that is the error in estimation et. The square of these terms are et square. So that's how we have got the so in this model actually we have to calculate d star and test the hypothesis. So it's not necessary to find out the standard error, but still if you have to calculate the standard error of beta hat, suppose, so we know that first of all we need to find out the variance. So here the variance is equals to that is variance of sigma u is equals to, that is summation et square by n minus 2. Okay, now from the table we know that summation et square is equals to 57.390. And there are 15 observations, so this is 13, and the answer here is 4.414 approximately. Okay, so from here now variance of beta hat is equals to sigma u square by, basically this is our sigma u square, right? That divided by summation xt square. Now this is our 4.414 divided by sigma t square is summation xt square is 280. So this will give us the value. Now if we do the variance of beta hat, then we will get the standard error of beta hat. So this way we can calculate it, though in here we only have to test for autocorrelation, so we don't really need this right now, because we know that to test autocorrelation we need the Durbin-Watson test, that is d star is equals to 2 into 1 minus rho hat, right? So for that, the Durbin-Watson test, test statistics, DW test statistics, is d star is equals to summation et minus 1 whole square by summation et square. So from the table, let us just find out the deviation square of et is this. The value is 73.660 and summation et square is 57.3. So let us write down 73.66 and 57.39. 73.66 by 57.39 approximately. So the answer that we have got is, that is 1.2 approximately. Now to test at 5% level of significance, level of significance, the lower limit of the Durbin-Watson test DL is equals to 1.8 and the upper limit is 1.36. Therefore 1.8 this is 1.08. Therefore the range here can be written as 1.08, this is less than 1.2, this is less than 1.36. That means DL less than D star less than DU. So this lies between these two values, and we know that if any value lies between the lower limit and upper limit of the D values at the particular level of significance, then the results are inconclusive, because the value should either lie on the left of DL or on the right of DU, right? So that is why here for this maths from the Durbin-Watson test, the result about autocorrelation is inconclusive.